You tell anyone who'll listen about their great service. But we're the only ones who'll reward them for it. It's the Small Business Awards with Softline Pastel. Small business, big rewards. Get your nominations in now.
Your family, your community, your country, your responsibility. Be the best citizen you can be. Find the Bill of Rights on leadersay.co.za.
The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Reedy Clubby.
It is 28 minutes to 10 o'clock and we go to the Naked Scientist. We're taking your calls on 021 446 0567 011 883 0702. Hello, Chris.
Good morning.
Are you well today? No cable theft happened?
No, they've got my cables back in place again. But that was only 5 times in the last
only
months.
5.
It's amazing, isn't it? Only 5 times.
We had a tragic one. You've been on the How train, have you? No, when you were here, you drove from the airport.
Well, I actually drove. In fact, Ben, who came with me, he drove me there because someone had to drive back again. So I was kind of chauffeured. I was lucky. Yeah.
So the How train is very new for us here in Gauteng, in South Africa. So they've just opened the route that takes you from Pretoria to Johannesburg just last week, Chris. And
the extra leg, because I saw that was about to open when I was there, and I was saying, well, that would be really good. Actually, I'd quite like to go for the extended journey.
Well, you wouldn't have been able to go for the extended journey 2 days ago because of cable theft. There was no transport. The How train wasn't operating on that route, so it's happening everywhere.
Oh no, that's a shame.
It was very disappointing.
Is it running now?
I don't know, actually. It is running. Okay, Thomas says it's running, but you can never take anything that Thomas says as the honest truth. Take it
apart
with a pinch
from
of
how
salt.
much he eats.
Yeah, that's true. All right. So tell me about this, the fungal free market economy. What's that about?
Well, many people probably don't realise that actually when you have a plant growing in the ground, it's a clever mutualistic relationship going on between the plant and fungi that live in the soil. These are called mycorrhizal relationships. And this collaboration between the plant world and the fungal world goes back hundreds of millions of years. In fact, some scientists say that plants could never have been so successful at invading the land about 400 million years ago if they hadn't teamed up with fungi to help them. The reason that this happens is that plants have photosynthesis. This is the ability to use the energy in sunlight to drive chemical reactions that produce big molecules like sugars from carbon dioxide. Fungi don't have that, but what fungi do have is lots of other clever biochemistry and a very big, extensive network of underground hyphae, these little tiny fungal filaments, which means that this massive fungal network can be used to collect nutrients and bring them to the roots of a plant. So what happens is that there's a sort of a bartering goes on. Plants give fungi sugars and things that they can't make, and in return the fungi give plants the nutrients like phosphorus that the plants can't make or can't obtain in sufficient amounts to grow well otherwise. And this relationship has been going on, as I say, for millions of years. But one big question is, well, how do you stop each other from cheating? Because when you've got that kind of relationship, there's always a temptation for somebody to start putting the price down. They'll take what you've got to offer, but they'll pay you less for it. So how do plants and fungi keep each other in check? And that was a question which was being asked by researchers in the Netherlands. This is Toby Keers, who's from Freer University. And what he and his colleagues did was to take 3 very closely related fungal species, and they grew them in a petri dish, culture dish in the lab, alongside the roots of a plant. It looks a bit like a little clover plant. It's called Medicago truncatula. That's the name of the plant they used. It's just a convenient experimental specimen. And what they were able to show is that there's this very clever kind of free market economy going on. When a fungus and a plant root meet, the amount of sugar that the plant gives to the fungus directly determines how much phosphorus the fungus gives back to the plant. But some fungi are more generous than others. And when you grow multiple different types of fungus together with one plant, the plants can tell which fungi are cheating them and which are being more generous. And they selectively reward the fungus which is the best one. And as a result, the fungus which is the more generous outcompetes the other ones because it's getting more sugar, and so on. And the way they did it was by using radioactive carbon dioxide to label the sugars in the plants and radioactive phosphorus to label the nutrients in the fungus, and seeing how they swapped between the two organisms. So a very elegant study been published this week in the journal Science.
That is fascinating, I'm telling you. Just this trade-off for mutual benefit. And then the other story about programming immune cells to pursue and kill blood cancers. How's that going?
Yeah, well, many people have heard of chemotherapy, the idea of trying to tackle a cancer by giving people various drugs which home in on fast-dividing or fast-growing cells like cancer cells and destroying them. The problem is that chemotherapy is indiscriminate, and it has all kinds of horrible side effects because it doesn't just take down cancer cells, it also harms healthy tissue, which is why people get things like their hair falling out, they lose lots of weight, they can get anemic and so on. So what researchers in more recent years have been trying to do is to actually use the fine, highly focused, highly targeted abilities of our own immune system to tackle cancer. And one very important group of cancers are the blood cancers, the leukemias and lymphomas, which are caused by cells that make up our blood running amok and becoming malignant. And there's a very interesting paper, it's in the journal Science Translational Medicine this week. It's by Michael Kalos and his colleagues. They're a group at the University of Pennsylvania. And what they have done is to take T cells, these are white blood cells that are endowed with the ability to home in on and destroy other cells in the body, including, say, cells that normally would be infected with a virus or something. And they take those white blood cells from a patient who has got a type of blood cancer. In this case, they looked at 3 patients with a disease called CLL, which is chronic lymphocytic leukemia. They take their white blood cells, their T cells, and they add to them a disabled virus, which adds to the cells a genetic construct, in other words, some pieces of DNA, which enable the cells to express on their surface a recognition protein, in other words, a kind of docking station for a certain marker which is expressed by the cancer cells. They then put those white blood cells back into the patients, and they do it in a series of steps so the patients don't get overwhelmed with too many cells at once, and they then followed them up. And of the 3 patients, after they received these modified cells back into their bloodstream, after 6 months, the cancer cells had been completely cleared from their peripheral blood. In 2 of the 3 patients, there was complete disease remission. The cells got into their bone marrow and even destroyed the cells that were causing the CLL in the first place in those patients. And excitingly, the infused cells also carried on policing the situation for many months, because one of the problems with doing this in the past has been that you put the cells in and then they very quickly disappear. And in this case, because of the way they've built the cells and constructed them with other signalling molecules that make them want to carry on growing, they were still detectable in these patients many months later. And this, say the researchers, is a very good way of achieving what's called immune surveillance. So if the disease pops up again somewhere else, you've got these cells waiting to delete the disease. And of course, it's only targeting the disease, it's not targeting healthy tissue. They reckon that each of the cells they infused, it individually got rid of 1,000 cancer cells, leading to the overall removal of more than 1 kilogram of tumour cells from each of these patients.
Alrighty then, let's go to the lines. We're taking your calls on 021 446 0567, 011 883 0702. Let's go to, is it Tapelo in Kempton Park? Good morning, Tapelo.
Morning, Rudy. Morning, Chris.
Yeah?
Hello, Tapelo.
I just want to ask Chris, my 3-year-old son, his pupils, they keep on like shrinking and extracting like most of the day. I don't know what causes that.
Hi, Tabello. Well, that's true for everybody, because what you have in your eye are rings of muscles called the ciliary muscles, and the ciliary muscles are in a circle around your pupil in your iris, and they are controlled by a special set of nerve cells which are in your brain stem, and according to how much light comes into your eye, your brain calculates how big or small to make the pupil so that you let the least amount of light through in order to see clearly. And that's because the bigger the pupil is, the more blurred the image is. So if you make the pupil nice and small, just like on a camera, you can get much better depth of focus with a small pupil because it works like a pinhole camera. And so this is a very clever bit of neurological programming, and it's done by a structure in the brainstem called the Edinger-Westphal nucleus. And the signal comes out of that nucleus and goes down to your eye and turns the muscles up or down according to how active you need them to be to make the pupil bigger and smaller. And it's tailored to how much light there is. So when it's very bright, very small pupil. When it's very, very dark or nighttime, the pupil gets very, very big. And you tend to see it in children because they tend to have quite big eyes relative to the size of their face. So because the eyes are a dominant feature on the face, you notice them more.
Yeah, but this happens for everybody, Chris. You did say that earlier.
And it's perfectly normal.
Yeah.
There are some abnormalities with pupil size, but they don't tend to affect both eyes at once. They tend to affect one eye only. And that's why you tend to notice them, because of the asymmetry. But if he's not complaining that his vision is compromised, then then it's probably just normal.
Okay, James in Blegauri. Oh, sorry, Janice in Blegauri. I beg your pardon.
Yeah, hi.
Hi there. Hi there.
Hi, Janice.
I've got a question. It's bugged me for months, and I'm hoping you can help. You know these pay-as-you-go systems when you pay for a parking whatever, and you put the coin in and it rejects your coin. And then if you scratch the coin on the surface, lots of these places have little scratching parts where you can scratch the coin, put it in, and then it works. Why is that?
I experience that all the time.
Now I'm going to be bugged by this because I've heard of that and I don't know how that works. So I'm not going to try and invent something. If someone knows or you run one of those machines, please tell us because I would like to know too. Otherwise, Janice, I'll take this away as homework and I'll come up with the answer for you for next week. How about that?
I'd love to get that answer, Chris, because it actually does work when you scratch the coin. But there's one particular shopping mall down the road from me. The security guard or the car guard comes through and stops you from doing that. They literally give you a lecture and they shout at you when you scratch the coin against the surface. And yet it works when you do that. So I don't know. All right, let's go to Audrey in Melbourne. Hi.
Hello, morning, Rudy. Chris, could you tell me, for 15 years, I've worn a copper bangle, never taken it off. And there are some weeks where it's a bright gold color, orange color, and then it suddenly changes and goes almost black. What causes that from the body components?
Hi, Audrey. Does your wrist go a nice corresponding green colour to go with the black bangle?
No, it doesn't.
You're lucky, because many people say that does happen. The reason that the bangle changes colour is because copper, the native metal, is a nice coppery colour. It's that pink colour. And when it oxidizes, it reacts with chiefly oxygen from the air and forms a form of copper oxide. This is a dark browny black colour. So when you look at coins that have become tarnished, they've actually got a layer of copper oxide on their surface. So something that's oozing out of you is making the bangle oxidize. The most likely ingredient is in sweat, and sweat is mildly acidic from your skin. There's also carbon dioxide dissolved in it, and this probably etches away the surface of the metal, making it a nice pink colour to start with. This then reacts with oxygen in the air when it dries off overnight, for example, and acquires a nice black colour. So I suspect it depends on how much sweat you're making to actually clean the bangle off, and then how much oxidation layer it builds up on the clean metal once it's been exposed in the first place.
Thank you very much, Audrey. And Cecil, Susan, Kivet, please stay on the line. I'm going to take your calls right after this.
The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Rudy Clubby.
13 minutes to 10 o'clock. Let's quickly go to Kivet in Brakpan. Good morning to you.
Good morning, Radio. Hi, Chris.
Hello.
I want to find out if we do a lot of drag racing. And if you build a drag race in the direction of, say, east to west, and you race in the opposite direction on the direction of the Earth's turn, will you do a quicker time over a measured distance, say 400 meters, like the quarter mile we raced, or will it stay the same if you race from west to east or east to west?
Do you do legal drag racing, Kivet? Is it legal, what you're doing?
Yeah, no, we do drag racing with a car.
And
if
Okay,
I know what you mean. I'll get on with answering the question then. Well, there are a lot of considerations here, which is that although the Earth may be turning towards you slightly faster as you're driving your dragster along the surface of the Earth, you've got to bear in mind that the wind is being pulled around in the atmosphere by the Earth turning. So if you drive in the direction that the Earth is turning, you're going with the wind, and if you drive in the direction against which the Earth is turning, although the Earth will be coming towards you a little bit relative to the direction you're trying to go in, the air will be coming as well. So as a result, you're going to meet a lot more air resistance. And you see this when you fly in an aeroplane. If you fly with the direction of turn of the Earth, in other words, it's turning towards the east, your flight time is much lower than if you fly against the direction of turn of the Earth. It sounds paradoxical because the Earth should be turning the opposite way you're going, so you should get there quicker, but you don't, because all of the air being pulled around with the Earth pushes you back on your aeroplane, so you have to burn more fuel and work harder to fly at the same speed relative to the ground as you otherwise would. So I would go with the wind if I was you, and good luck with your racing.
If it's legal, Kivet, but if it's not legal, the police phone me now, I'm going to have to give them your contact details, I'm afraid. Let's go to Cecil in Orange Grove. Hi.
Hello, good morning, Rudy. Good morning, Dr. Chris.
Yeah.
Dr. Chris, I have a two-part question, please. If we take 1 gallon of water, which weighs 10 pounds, and freeze it, is there any weight differential between the water and the ice that we've made? The reason for me asking is, take a large glass of water, put ice cubes into that glass of water. The ice cubes tend to float near the surface of the water. Thank you, Dr. Chris.
Okay. If we assume that we're not talking quantum mechanics, the answer is that there isn't a difference in the mass of the ice. The ice actually has slightly less energy, so I would think it would be a slightly less massive at a minute level. But thinking entirely Newtonian physics and big stuff, basically when you take water and you freeze it, the molecules that have turned from water into ice remain exactly the same. There's the same number of them. They're just configured in space slightly differently, and they take up more space as ice than they do as water. And because they take up more space, the same mass is distributed over a bigger area, and therefore, or a bigger volume, and therefore the density of ice is lower than the density of water, but the actual mass will remain the same. And because the density of the ice is lower than the density of the water, then the ice cube will float. But it's actually pushing out of the way exactly the same amount of water in terms of mass that the ice weighs, and when the ice cube melts, therefore, it will just turn into that corresponding volume of water. So your drink, assuming you filled the glass right to the top and had ice bobbing around in it, your drink will not overflow when the ice melts.
Okay, Cecil, does that answer your question?
Does that the same apply to Dr. Chris to icebergs then?
It absolutely does, except an iceberg is like a giant ice cube, and this is the point about melting of ice sheets. If you look at the Arctic and the North Pole, most of the ice in the North Pole is actually floating. Therefore, it's already displacing most of the water that it's going to displace out of the way already. There is some ice on land. If you take Greenland as an alternative, this ice is taking up space on land. It is not pushing any water out of the way, and therefore when it melts, unlike the North Polar ice, the Greenland ice flows into the sea and pushes the water level up.
We've got Craig calling us, and Craig, you manufacture those coin machines that we were talking about earlier.
Yes, absolutely. Mm-hmm. Yeah, we're a Swiss company that manufactures the equipment. I believe you were talking about the coin acceptance.
Yes. And you're saying that it makes no difference, but it does, Craig. I've experienced it. I promise you.
I've had people ask me this, but I would be delighted to know how this works.
Yes.
You have what you call an acceptance window on a coin unit. Now, if you didn't waste the time scratching the coin and just took the coin and popped it back in there, effectively what's happening is it's falling in at different angles, and at some stage or another it'll catch within that acceptance window and allow the coin to be accepted.
Whether you scratched it or not.
Whether you scratched it or not. It makes absolutely no difference. But this isn't a South African thing. This is an international thing. It's an international perception. It's quite interesting from,
Craig, you know what, my darling? I'm going to continue scratching, okay? Just for my own peace of mind.
Go for it.
Thanks, Craig.
From a perspective, I think I would reserve comment to say that we're damaging coins when we do that. But if you feel better because of it, then by all means.
Thanks for calling. That's very gracious.
Yeah, it'll make no difference whatsoever.
I don't know about that, but thanks, Craig. Thank you. And there'll be situations. What happens then, Craig, when it rejects the same coin over and over again? Because that also happens. You put in the 5 Rand coin, it rejects. The second time, third time, fourth time, and then you find those guys who are singing at the parking lot, helping you along and exchanging 5 Rand coins to give you the suitable one.
In essence, what happened a little while ago was the Reserve Bank swapped there, for example, it's generally speaking the 5 Rand coins. And the Reserve Bank swapped out those coins because of the fact that there was a large amount of fraudulent coins in the process or in circulation. So what you often find is that you've got either a fraudulent coin or a very worn coin. And if it's been in circulation for a period of time, it doesn't fall into the acceptance window. And remember, you're dealing with an electronic eye, which can't look at the coin physically and say that for definite is a coin. So it's got to rely on certain characteristics.
Craig, lovely call. Thanks indeed. Hey, thanks for calling. Bye-bye.
Bye-bye.
Bye-bye. Susan in Bryanston.
Yes, hi. I'm calling to find out about the usefulness to the body of glyconutrients. I was approached by someone who was marketing these products. They noticed I had small joint arthritis in my hand. And they said that this is sort of a miracle thing, these lyconutrients, that we don't get sufficient from the soil nowadays, and that, in fact, they can cure just about anything, including cancer in the body.
Chris?
Oh, hello, Susan. As soon as people start using the word miracle and cure in the same sentence, my alarm bells start ringing. So I would advise you to do the same when people try and tell you things like that sounds too good to be true medicinally, probably worthy of enormous scepticism. They want to sell you something and they want your hard-earned money, and they don't really care whether or not it works or not. If they have got good clinical evidence that one of their products works, then they'll have a trial. They'll actually have data where they've put patients on a placebo, a dummy drug, versus patients with the same problem on the real drug, or even the same patient initially on a placebo, then on the real drug. They'd have followed them up medically and properly in a blind fashion, so no one knew what anyone was getting. They just measured how their health went, and if you've got that kind of level of data to support a product, then, and they can show it to you, then their product might have some validity. If they haven't got that kind of data, ask for it. If it never is forthcoming, they probably haven't got it at all, and therefore it's probably not worthwhile buying their product. There was a lot of hype around these kind of things about 5 to 10 years ago. Lots of people started using them, especially for things like arthritis, as you say, glucosamine tablets and things like that. There was a trial published in the British Medical Journal, or at least reported there, in the last year or so, and they found that there was no actual evidence that they made any difference to people's disease outcomes. So I'm a bit sceptical myself as to whether they're going to be the panacea everyone says.
All right, Lindy in Santon, hi.
Hi, Rudy. Hi, Chris. I just want to find out, this might sound silly. In winter, I sweat only in my nose. Summer, okay, I can sweat other places, but my nose would be the first one. But in winter, you know, why is that? And my two other children, they have that, you know, as well.
All right, sweating on the nose.
Do you mean sweating actually on the outside of the nose, Lindsay, or do you mean actually as you get a runny nose in winter?
On the outside of the nose?
Just sweating, like on the outside of the nose.
Okay.
Yeah. Well, I think probably what may appear to be sweat could actually be just normal skin secretions, because the face is covered, as is most of the body, is covered in tiny glands which secrete various chemicals, including oils and greases and things, to nourish and protect the skin. And in wintertime, when the environment is harsher, it's windier, and skin gets dried out more, then the secretions can increase to compensate. And it may be that you're just noticing, because they're being produced more often, you're noticing the stuff collecting there more often, because you do get this little kind of glistening layer on the skin, which is the skin's natural secretions nourishing it. And it might just be that you're increasing the production in wintertime because of things like wind and temperature. And when you go indoors, because the secretion doesn't switch off immediately when you go indoors, you're going to notice it's there slightly more. In the summer, the sweat evaporates more quickly, and breezes and warm weather will blow the stuff away more quickly, so you may not notice it so much.
Okay, Chris, lovely chatting to you. We'll see you again next week.
All right, thanks for having me. Thanks also to Craig for the wonderful coin answer.
Yes,
that was great.
Absolutely. Loved it. We'll podcast all of that and more. Thanks, Chris. Bye-bye.
See you soon, Reedy. Bye-bye.